Okay, welcome. We'll try this again. I'm going to go ahead and attempt to do a short integration by parts video doing a quick example. So I'll go ahead and go to, I'll get my software set up, which I would ordinarily do at the beginning. Let's see here. All right. Okay. All right, now we got it open. So I'm going to go to share screen. All right, now hopefully this is going along right here. So now let's do this integration by parts problem. Let's go ahead and say we want to do the dreaded e to the x sine of x dx problem. We wish to do this by parts. First thing, you better be able to see it. So I set the, okay, so I set that. And let's see if I can get a little bit brighter. That's a little brighter. So we go ahead and we need to start somewhere. So let's start with, and remember, we're using the formula u dv equal uv minus integral of v du. So let's go ahead and try to do that. Let's say u is e to the x, dv is sine of x. Okay? Now, this is probably not the best choice, but it'll work, because then we say du is still e to the x, v is minus cosine of x. So in fact, we get, and we have to keep this going here, because there's your uv minus cosine x e to the x minus cosine x e to the x dx. So we have this written down like so. Plus the integral of cosine x e to the x dx. Now, this has been reduced. Now, in this case, this doesn't look any easier than the beginning, but here's a little trick. If we do this by parts again, and we keep the same scheme we kept here, and then I'll do an example to show you what goes wrong if you don't keep the same scheme. Let's do this again. I'm going to go ahead and use u as e to the x, dv is cosine x. That means du is e to the x, and v is sine of x. What we get out of this is we get uv minus the integral of e du. So it's going to be minus e to the x sine x dx. Now, what's interesting here is, remember, we have this parentheses. So we now have e to the x sine x dx. And I'm going to combine these two. So I have a sine x minus cosine x. And I'm going to go ahead and distribute that e to the x on the outside. Now, in a class, I probably would do that in 2 steps. And I do have this particular thing here. Now notice, this quantity appears on this side of the equation as a negative. This quantity here appears on this side of the equation as a positive. So what I can do is I can add this to both sides. And I obtain this. Then a simple division by 2 gives us up to constant our answer. Now, the fuzzy student might wonder, hey, how did this constant just appear out of nowhere? Well, remember the constant's implicit in this antiderivative and this antiderivative. So if I were being precise, I would have of the c is built in here. So I'm just ignoring it until the very end, which is safe to do with these additive constants. Now, what I'd like to finish the short video is to notice that this worked because we made the same type of substitution. We used u, v, and e to the x. Now, what happens at this stage if we made a different choice? Well, here, instead of using that, suppose I decided to let u equal sine of x, cosine x, dv is e dx. Well, then I get uv and our du is minus sine of x. And what happens is if I plug this in, I get a cosine x e dx minus a minus e dx sine x dx. And then when I take the parentheses away, look what happens. These 0, and I get integral of e dx sine x dx as e dx sine x dx. That's not very, it's true, but it's not very helpful. So you see, the key is whatever choice you made here, you have to make it this stage as well. And that's how you handle something like e dx sine x. Okay? And I will end this short video here.